Today's lesson is on section 6.1, solve inequalities using addition and subtraction. I'm actually going to go through 6.1 and 6.2 today because they both are very similar, both solving one-step inequalities. At this point, I'll usually ask the student what are inequalities, and I'll try to kind of jog their memory on a few hints on what they might be, but it's usually something they can come up with. Inequalities, looking at the word in, the prefix in means like not, so not equal is what we're looking at, something that's not equal. Well, if they're not equal like equations are, then what are things that could be a phrase like that or some kind of statement that is unequal? Well, those are the four inequalities that we have up here. Less than, greater than, less than or equal to, and greater than or equal to. And again, these are things the students have seen before, and we'll be working with these. The nice thing with solving inequalities, as we'll be doing, is they solve just like equations. If you're taking notes, here's this little note I'd like you to write down about solving inequalities. So this first section in chapter 6, we're not actually learning too much new. We'll learn how inequalities are a little different. The set of solutions means something different. But in terms of the steps for solving an inequality, it's just like the steps for solving an equation. So that will seem very familiar to us, and we'll be able to do things that we've learned in the past already. So for example, I've got an equation right here. And again, way back in chapter 3, we learned how to solve equations like this, as a two-step equation. I can draw my line as a reminder to tell myself whatever I do to one side, I got to do to the other. But I'm trying to solve this and get the variable by itself, x. So what I would do is I do the inverse of what they're doing with the variable. So I'm going to subtract 5 from both sides. That'll get rid of the 5's on the left side. On the right side, I'll have 6. Over here, I still have this 2x, so that comes down to the next level. 2x equals 6. Divide both sides by 2. I get x equals 3. So again, that should look pretty familiar to students. We've solved equations before. That's nothing new. There's the steps that we used. When I'm solving an inequality, what do you know? I'm going to use the exact same steps. So if I'm solving this inequality, as opposed to an equal sign here, though, it's just got a greater than sign. But that's really the only difference. The numbers are all the same. So what do? I could still draw my line if I like, to remind myself whatever I do on one side, I have to do on the other. My first step would still be subtract 5 from both sides. I'd get 2x is greater than 6, and then dividing both sides by 2. Just kind of erasing the line here so I can see it completely. I'd get x is greater than 3. At this point, here's where they become different, though. An equation is saying that x equals 3. For the original equation, that's the one answer that's the possible solution. X equals 3. If I put 3 back into the equation, it's the only thing that can make it true. 2 times 3 would give me 6. Plus 5, yep, that gives me 11. Okay, 3 is the one possible answer that can work in there. In an inequality, as I've got written up here and as I wanted you to write in your notes, we have a set of solutions. We have a lot of numbers that are a possible solution for that original inequality. Because all we need is for this side to be bigger than this side. So as long as I can put in a number that would give me a number greater than 11 on the left side, then that's what'll work. Well, there's a lot of possible numbers, and as I'm seeing here, it's any number greater than 3. X has to be greater than 3. If x is 3, it wouldn't work, though. It'd have to be, if it was greater than or equal to, that's the case where 3 could be a possible answer too, but any number greater. 3.1 would work. 4 would work. 8 would work. 1,000 would work. If I plug a number in here, greater than 3, it should give me a number greater than 11 on the other side. So let's put a number like 4. 2 times 4 would be 8. Plus 5 would give me 13. Yep, that's greater than 11. If I put in the number 1,000, 2 times 1,000 would be 2,000. Plus 5 would be 2,005. That's still greater than 11. So you understand, here's the big difference with inequalities. There is a big difference between an equation and an inequality. Is the set of answers is much, much, much larger for inequalities. There's an infinite amount of answers that can work. This is the inequality that shows it to us. And then to show this visually, we'll also talk about graphing inequalities on the next page. So like I was talking about with that previous example, an equation only has one answer that works for the original equation. That's why we solve it, to find what that particular answer is. An inequality has a set of solutions, many solutions. And what we do, as I've gotten written here, is that usually you'll shade in all those answers and use a number line graph. This is just kind of a visual representation of all the possible answers for that inequality. So let's try to graph this inequality right here. X is less than or equal to 3. Well, to graph an inequality, there's two kind of things we got to keep an eye on. One, whatever the key number is here, 3, we're going to circle that number. Sometimes we're going to fill that number in, sometimes we're going to, or that circle in, sometimes we're just going to leave it open like that. Think about this. As it says up here, I want to shade in the numbers that are solutions to this inequality. So x is less than or equal to 3. So could x be 3? Yes, it could. So that's a number that I'm going to shade in. I'm going to shade in the 3 in this case. Whenever it can be equal to, it's got that little line underneath, then I should have a closed circle, as we call it. I shade in 3. Then, as I read this, it says x is less than or equal to 3. So x has to be all numbers that are less than 3. Well, where are those numbers on the number line? Well, that's numbers like 2, 1, 0, all the negative numbers. So these are the numbers that I want to shade in. So here's what it looks like to graph that inequality. A closed circle on the key number there, 3, and then I shade to the left. All those numbers are solutions to that inequality. Going down to another one here, x is greater than negative 4. This one, with x being greater than negative 4, that's the solutions. Negative 4 is not a possible answer. So negative 4 is still the number I want to start on, but I'm going to put an open circle on negative 4. X can be anything greater than negative 4. It could be negative 3.9, which would be right here, right next to it, okay? Or negative 3.5 right here, okay? But it just can't be negative 4. It has to be anything just even a little bit bigger, but not negative 4. So that's why I leave an open circle on that. And if I want all the numbers then greater than, I'm going to shade to the right. All these numbers are greater than negative 4. They're all solutions to that inequality. But since negative 4 is in itself, I leave that circle open. Add this to what you already have written down about the inequalities. Okay. If you don't have this written down already, I want you to write down this box with the 4 inequalities. Greater than, less than, greater than or equal to, less than or equal to. And then just add this to it. Less than and greater than. For those, I need to have an open circle when I'm graphing. For greater than or equal to and less than or equal to, those I'm going to have a closed circle when I'm graphing. So just going through a few examples here. Problem that they might say, solve and graph the inequality. And here's the one we're trying to solve and graph. And what I'm trying to get you to realize is that we don't have to learn any new steps to do this in Chapter 6. Think about the steps you would use to solve this equation right here. It's the same exact steps you would use to solve the inequality. X minus 14 equals negative 16. Well, in this equation, when we were starting to learn equations, we knew we would add 14 to both sides. And that would give me the solution, x is equal to negative 2. Well, same thing in an inequality. I'm going to add 14 to both sides. I'm going to get x's, in this case, instead of equals, though, I'm just going to get x's less than negative 2. When I'm graphing in an inequality, or when you're doing them in your homework, you don't have to make a big elaborate number line like the ones I've had up here so far. If you just put the key number, so in this case that's a negative 2, and then just a couple numbers around it so I know that you know which direction to go, that's all I need for a number line. So negative 2 the key number, and then some numbers nearby it. Well, in this case, what type of circle should I have on negative 2? Well, since it doesn't have the line underneath here for this inequality, it's just x is less than negative 2. That means x could not be negative 2. So that's my key number. I'm going to circle it, but I'm just going to leave that circle open because I can't have a solution of negative 2. Then I want all solutions that are less than negative 2. Okay. Well, think to yourself, what numbers are less than negative 2? Well, those are numbers that are more negative. So in this case, I'm going to shade to the left. Numbers that are more negative, like negative 3, negative 4, negative 5. If I'm thinking in terms of money, I'm going more into debt. That's a number that's less than negative 2. So I'm going to shade to the left. Just going through another example here. Again, 5x is less than or equal to 35. This is kind of where section 6.2 starts. But again, realize it's still just one-step inequalities like we've been solving. 5x is less than or equal to 35. Again, if it helps, think about how would you solve this equation. It's the exact same kind of steps you're going to do to solve this particular inequality. So I'm going to divide both sides by 5. X is less than or equal to 7 in this case. For x is less than or equal to 7, that means that a solution could be 7. Okay, it could be equal to it. So in this case, I'm going to close the circle. I'm going to fill it in. And then numbers that are less than 7, I'm going to shade to the left. All these numbers are less than 7, so I shade them all in, and then put an arrow at the end to say that the line goes on for infinity, forever, on to the left side. All numbers that you can think of that are less than 7, all the negative numbers, anything. So I put an arrow at the end. It says that line goes on forever. There's an infinite amount of answers for this inequality, and the graph shows that all numbers left of 7. Now, if that was all to show you about inequalities, then I could probably at this point hand out the homework in the lesson, and people could go forward and do just fine on it. But there is one more key thing we need to talk about when we're solving inequalities. I'm going to show it on this particular page. Inequalities solve just like equations, all the same steps, but there is one situation we have to watch out for that happens with inequalities that we have to kind of fix it so that we get the correct answers, and it's in one of these two problems here. Okay. First, I'll show you number 2. Number 2 says t divided by 3 is less than -1. How would I solve this one? Well, since it's t divided by 3, I would have to multiply both sides by 3. That would get rid of the 3's for me. I'd have t is less than, well, -1 times 3 would give me -3. So there'd be my solved inequality. What would the graph of this look like? Well, here's -3, here's -4, here's -2. It'd be an open circle on -3 because it's just less than. And I'd be shading to the left in this case. All numbers that are less than. The numbers that are more negative are less than -3. So that one's fine. That one actually I can solve just normal. No problems there. Number 3 here though, this is the one thing we have to watch out for inequalities that happens in a problem like this. It says -7x is greater than or equal to 56. Well, to solve this one, just like solving an equation, I would divide both sides by -7. When I do that, I get x is greater than or equal to -8. And if I start graphing it, I could say -8, -9. I'll just put a few numbers on here for this one to kind of show what happens. -8, I'd have a closed circle on -8, and I'd want to shade all the numbers that are greater than. So here's what the graph of that one looked like. And I would probably think that's good, and I would go on to the next problem if I didn't know what I'm about to tell you about inequalities. There's one kind of, as I'll call it, a glitch that happens when we're solving inequalities that students need to be aware of. Let's look at what I got for the answers here for this inequality. I'm saying that numbers like -7 and -6 should work or make this inequality true. Well, let's plug in -7 and see what happens. Well, this would be -7 times -7, which is supposed to be greater than 56. -7 times -7 gives me positive 49, which is not greater than 56. So right away, I can see there's a problem here. I'm saying that -7 is a solution, but it's not working in the inequality. Try -6 as well. -6 times -7 gives me 42. Well, that also isn't greater than 56. So there's a problem with the answers that I got for this inequality. Here's what happens in a problem like this, and usually I'll ask students to kind of think about it for a little bit and see if they can tell what's different about this problem than any other problem we've done so far. And here is the big difference. In this problem, we divided both sides by a negative number. We divided by -7 on both sides. When this happens in an inequality, what you actually have to do is flip the inequality sign around to get all the correct answers, because dividing both sides by a negative number essentially changes the sign of both the sides. On the left side, I used to have a negative number. Now I've got a positive number here down on the left side. I used to have a positive number here. Now I've got a negative number. It changes the sign. And so in doing that, to make sure I get all the correct answers, then I have to just switch the sign around. The way I visually show this is whenever that step happens, I circle the inequality and that sign in that step, and then I drop an arrow down to remind myself, okay, in the next step, I have to make sure that I switch it around. So this problem really should be answered x is less than or equal to -8. All the other numbers work out, and everything else is fine, but I just have to switch the inequality around. It should be x is less than or equal to -8. I would close circle on -8 and shade to the left instead, and that will give me all the correct answers. -10 times -7 would give me 70, and that is greater than 56. So they're just showing that the answers do work on the other side. Here's the rule, or just the kind of little words that I've written here that I want you to write down in your notes to remember that. I'm just calling it the negative rule for inequalities. And I showed the problem above that, number 2. I showed the problem above here, number 2, because to show you it doesn't matter if you have a negative number in the problem. That doesn't affect things. Okay? In this problem, there was a -1 over here, but that doesn't mean I have to change the sign. The only time you have to change the sign, going back to this problem right here, is when I divided by -7. When I divide or multiply both sides by a negative number, then I have to flip the inequality around. If it was less than, it's now got to be greater than. If it was greater than, it's now got to be less than. And I'll show that with one more example here. K divided by 2 is less than -2. So in this problem right here, I would have to multiply both sides by -2. When I do that, that's the step right there where I'm going to say to myself, well, now I've got to switch the inequality around. It was less than, now it's got to be greater than. Once I get that out of the way, the rest of the problem is just like normal when I'm solving an inequality. The -2's on the left side cancel out. I get K by itself. -2 times -2 just gives me 4. And since I switched the inequality around, now the problem should work just fine. My solutions. Open circle on 4, shade to the right. I'm saying the answers like 5, 6, and 7 should work in this original inequality. If I plug 5 in up there, 5 divided by -2, is that less than -2? Well, 5 divided by -2 gives me -2.5. So yeah, that is less than -2, so that does check out. So just showing that yes, once I switch the inequality around, then it works just like normal and all the solutions are fine just like they were when I solved it normally. But that's the one thing I have to keep an eye on for inequalities. Otherwise, inequalities solved just like any other equation, like any other problems, the same kind of steps. But I just have to make sure that when I divide or multiply by a negative number, I got to flip the inequality around. If it was greater than or equal to, it's now got to be less than or equal to. If it was less than, it's now got to be greater than. Just one more page to show that and just make sure we understand. So of these 3 problems, think to yourself right now, which of these 3 problems would I have to switch the inequality around when I'm solving it? Of these 3 problems, there's one of them, one of the 3 problems. Well, I'll eliminate, think to yourself, hopefully you got a kind of an answer in your head here. But of these 3 problems, I can eliminate, I'll show you one that I can eliminate, number 2 for sure, because it doesn't have a negative number. Number 2, I would just multiply both sides by 7 and get x is less than 28. And that'd be my answer. I wouldn't have to switch that one around. Of 1 and 3, one of those I have to switch the inequality around when I would solve it. And which one is it? It actually ends up being number 3. Number 3, I have to divide both sides by -3. Since I'm dividing by a negative number, I have to switch this around, or in this case, I guess I could bring it over here, but from greater than to less than. And that would make my solutions correct. In number 1, there's a negative number, but I'm still just dividing by +10. So I don't have to switch that inequality around. It's still x is greater than or equal to -6. The only time I have to switch an inequality around that I have to be aware of, any time I'm solving an inequality, whether it's a 1-step, 2-step, 4-step, doesn't matter. If at some point during an inequality solving it, you divide or multiply by a negative number, you've got to flip the inequality around. Otherwise, they solve just like equations, just like we've learned before.